All right, we're going to continue on today with learning how to read the periodic table of the elements and the information that it can give to us. So let's just pick a random element. Who's got a favorite element? Gold, that's a good one. Let's find gold. Gold has the number 79 above it, and its symbol is a U. And underneath it, it says 196.97. That 196.97 can be the most confusing part of the periodic table of the elements because it's difficult to understand. We know that the identity of gold comes from the fact that there is 79 protons. If somebody tells you, oh, no, I have gold and it has 80 protons, and you're like, no, then you have mercury. That's the identity. When we're talking about an atom, which is not an ion, an atom is electrically neutral, so that means it has just as many plus charges as it has minus charges. Who remembers what are minus charges in chemistry class? They're the electrons. So when we have an atom of gold, it has 79 protons or plus charges and 79 minus charges. And plus 79 minus 79 gives us 0. All atoms are electrically neutral. If you have an ion of gold, remember the two common ions of gold are +1 and +3. You get +1 when it loses an electron. You get +3 when it loses 3 electrons. But we're going to deal only in atoms today. So if you find gold laying around by itself, which gold is one of the elements you can find laying around by itself, it's what we call a noble metal. So he's okay hanging and chilling by himself. Not many metals are. He will be an atom of gold. Now, there can be different golds, though, and they're called isotopes. Isotopes of gold have the same number of protons, otherwise it wouldn't be gold anymore, but a different number of neutrons. So the two different kinds of gold are gold 196 and gold 197. So both of them have 79 protons, but they have a different number of neutrons. So let's remind ourselves, the mass of a proton is 1 AMU. The mass of a neutron is 1 AMU. The mass of an electron is 0 AMUs. But we're going to clarify the fact that not actually 0. Electrons are matter, they have mass, they take up space, but they're just so small that we don't consider their mass when we're coming up with the mass of an atom. I'm getting a calculator for this. So gold 196 has 117 neutrons. Remember, neutrons have mass. They don't have any charge. Gold 197 has 118 neutrons. Those are two isotopes of gold. Now let's try to remind ourselves what that means. So not one single atom of gold has a mass of 196.97. The analogy that I always use is in the United States of America, families have an average of 2.3 children. We all know that a family can't have 2.3 children. You can either have 0 children, 1 child, 2 children, 3 children, 4 children, so on and so forth. Nobody has 2.3 children. That's just the average. So not one single atom of gold has a mass of 196.97. They either have a mass of 196 or 197. Maybe a stray 198. The average atomic mass is 196.97. Just like the average family has 2.3 children, the average mass is 196.97. That also means when I take a huge sample of gold, or 6.02 times 10 to the 23rd atoms of gold, or 1 mole of gold, it will have a mass of 196.97 grams. That's another thing that tells us. Let's do one more before we go to our next part of this. Who else has a favorite element besides gold? Yes.
Cobalt.
Cobalt? That's a good one. You know what color cobalt is?
Color?
So cobalt, when it is an atom, is a metal. Therefore, it's silver. But when it's an ion, can anybody guess what color cobalt is? Yes.
It's like a deep blue.
It's blue, cobalt blue. So they didn't just make up that color. Cobalt's actually really pretty blue. So if you look on the periodic table of the elements, you'll see that cobalt has a 27 above it. That means that's the number of protons. And it has a 58.93 underneath it, which is the average atomic mass. Who's good with numbers? Is there more cobalt 58 or more cobalt 59? More 59. So probably about 93% 59 and about 7% 58, something like that. So let's analyze this. Each of the cobalts has 27 protons. They're atoms when we're talking about atoms. So there's going to be 27 electrons, and they will be electrically neutral. The difference will be in the number of neutrons. So isotope means iso in front of any word always means the same. So they have the same number of protons, they're the same element, but they have different number of neutrons or different masses. So the mass comes from protons plus neutrons. That's because the electrons are so small, we don't consider the mass. It's like 1/2000th of them. So we can analyze this, and we can say if it has a mass of 58, 27 of that comes from protons. That means that this one will have 31 neutrons, and this one will have 32 neutrons. There's a fancy piece of equipment called a mass spectrometer, and that mass spectrometer separates things by masses. As you can imagine, when you start shooting things, if you know anything about physics, you start shooting things down a trajectory. The heavier it is, the quicker it'll stop. So the lighter atoms go further, the heavier atoms don't, and you can separate them by mass. Remember, not one atom of cobalt has a mass of 58.93, but if you took 6.02 of them, lots of them, times 10 to the 23rd atoms, it would be a random sampling, would have 58.93 grams per mole. So you might say to yourself, why is this important? We use isotopes in all sorts of different things. Has anybody ever heard of some uses of isotopes? We're going to do an activity where we can see some of the uses of isotopes. But you might be too young to remember this, but have you ever heard of that tsunami that killed over 200,000 people? It's a pretty crazy story, isn't it? That'd be one to Google. I was alive during it, and I still don't believe it. Imagine over 200,000 people dying. Now, how do you identify all those people? Does anybody know how we identify bodies in this country? DNA would be one way. Anything else? What do we use if somebody was unidentified to identify a body? Dental records. You guys don't watch those crime shows? What else would you use to identify a person? You got dental records, you got DNA, fingerprints. But let's think about this. Most of the people who died were from third world nations. Do you think they have dentists in third world nations? If you've been to a dentist, you're already in the top 5% of the richest people on this planet. You might not feel so lucky going to the dentist, do you? But you are lucky going to the dentist. So there aren't dental records for most people. If you investigate it, there's quite a large percentage of people in the United States of America that have never been to a dentist. So if your parents take you to the dentist, you can already consider yourself well taken care of. How about fingerprints? Anybody here been fingerprinted? I only have because I'm a teacher and they need to make sure I don't have a criminal record before they send me in a classroom. But I wasn't fingerprinted until I was a grown person. How about DNA? Is anybody given their DNA? Maybe if you did like that 23andMe stuff or something like that. That stuff makes me nervous, so I haven't done that. They don't have my DNA. So in order to identify all these people and try to get them back to their loved ones, they looked at isotopic abundance. So if you looked at the periodic table of the elements in a different country, that might have different masses. Some of the names are going to be a little different too, based on the language here. So depending on where you live, you have different isotopic abundances of different elements. So that's why these numbers are not set in stone. You're dealing with individual samples. In this country, we still have isotopes in our system from when Mount St. Helens exploded. If you live in, which is a volcano that exploded in the 80s in Washington. If you lived in Russia, you would still have isotopes from Chernobyl meltdown. And you might think, well, not me. I haven't been around that long. But you definitely incorporate it into your system when you eat food that breathes the air, so on and so forth. Okay, let's take this to the next step. My two isotopes of lithium are lithium-6 and lithium-7. Now, because neutrons aren't exactly 1.0000 AMUs and electrons aren't exactly a mass of 0, the exact mass in AMUs is going to be a little bit different than 6. We call it lithium-6 because when it comes to sig figs, we're going to round it to 6. But we have fancy special equipment that tells us the exact mass of each isotope. These are the exact masses of each isotope. Then you can take your sample and with a mass spectrometer, it can separate it by atom and it'll tell us that we have 7.49% lithium-6 and 92.51% lithium-7. So where does this number on the periodic table of the elements come from? Is we calculate the mass, 6.0151, and then we take this percentage and turn it back into a decimal. So remember, to turn it into a percentage, what did we multiply it by? 100. So to turn it back into a decimal, we're going to divide by 100 or move the decimal point over 2. We'll add these two isotopes together. Like such. Look at my 7%. I got to make sure I move it over 2 decimal points. And those will equal the molar mass U is a short for AMU. That means if I took one atom, it would either have a mass of 6.0151 or 7.0160. The average atomic mass would be 6.941. That's what goes on the periodic table of the elements. That means if I took a huge sample in the United States of America, or 6.02 times 10 to the 23rd atoms, or 1 mole, it would have a mass of 6.941 grams per mole. So let's summarize this. You take the mass times the percent as a decimal, and then you add them to all the other isotopes. And that's going to equal the average atomic mass, which is going to come straight from the periodic table. That's kind of a general formula. If you had 3 isotopes, you just add them all together. You have 4, you add them all together. Multiply the mass times the percent as a decimal of all of them. You add them together, and they should equal the number off the periodic table of the elements. If this is brand new to you and you need a little bit more help with reading the periodic table of the elements, try to figure that out tonight. I have a link to the video from first year of how to read the periodic table of the elements, which is called Barium from the Periodic Table or Barium from the PT. And then we'll review this little part of it again tomorrow, okay? We'll review the figuring out the average atomic mass, which is part of the problems that I gave you today.